You know the feeling. You have one job to do today. Just one. But instead of doing it, you've spent 3 hours organizing your desktop icons, researching the history of the Roman Empire, or scrolling until your thumb hurts. Oftentimes, we blame ourselves for this. You tell yourself you're just lazy, you lack discipline, you're broken. But what if I told you that laziness isn't a personality flaw? What if it's actually a survival mechanism that kept your ancestors alive? Science suggests that the guilt you feel right now is actually a software mismatch. Your brain isn't broken. It's actually doing exactly what evolution designed it to do. Let's look at the hard data. A study from the University of Geneva put this laziness instinct to the test. Researchers hooked participants up to an EEG and discovered something known as the physical activity paradox. They found that while you can choose to be active, your brain physically struggles to do it. Specifically, the study showed that to choose action over rest, your brain has to recruit significantly more cortical resources. It wasn't a lack of ability, it was a massive spike in neural cost. Your brain is hardwired to fight against unnecessary effort. Why? Because of the thrifty gene adaptation. In the prehistoric savanna, calories were rare. If you ran for no reason, you burned energy you might need to run from a predator later. If you wasted energy, you died. The humans who survived, our ancestors, were the ones who were really, really good at conserving energy. This constant calculation happens in a specific part of your brain called the anterior cingulate cortex, or ACC. Think of the ACC as your brain's ruthless accountant. It constantly runs a real-time cost-benefit analysis. Is the reward of doing this task worth the caloric expense? When you perceive a task as hard or emotionally draining, like an overwhelming email inbox or a complex financial report, your ACC lights up with a signal similar to physical pain. It tells you that the cost is too high. So when you can't get off the couch, you aren't being bad. Your inner accountant is just rejecting the invoice because it perceives the effort as a dangerous expenditure for a payoff that's too far in the future. If evolution explains why we are lazy, neuroscience explains how it happens. Inside your skull, there is a civil war. On one side, you have the prefrontal cortex. This is the newest part of the brain, responsible for long-term planning, logic, and your dream life. On the other side, you have the limbic system, specifically the amygdala. This is the ancient, emotional center. It only cares about two things: immediate safety and immediate comfort. When you look at a difficult task like writing a complex report, your prefrontal cortex sees a task, but your amygdala sees a threat. The task looks hard. It might result in failure. It's scary. So your amygdala hits the panic button. This is often called the amygdala hijack. Your brain triggers a fight or flight response. Since you can't physically fight a spreadsheet, you choose flight. You flee to the safety of your phone. But there is another player in this war: dopamine. And this is where most people get it wrong. You don't just need more dopamine. You need the right kind. Neuroscientists distinguish between tonic dopamine, your baseline level, and phasic dopamine, spikes. When you scroll on your phone, you get phasic spikes, quick, cheap hits of reward. But deep work requires high tonic dopamine, a steady background motivation that makes effort feel good. Here is the trap. When you flood your brain with cheap phasic dopamine from your phone, your baseline tonic levels actually drop to compensate. This makes the hard work feel even harder and more boring by comparison. You aren't lazy, you are just in a high phasic, low tonic state that makes productivity chemically impossible. This brings us to a specific type of laziness that is ruining your life in 2025: revenge bedtime procrastination. Have you ever stayed up until 2 a.m. watching videos you don't even like, knowing you'll be tired tomorrow? This phenomenon is a response to a lack of daytime autonomy. If your day belongs to your boss, your kids, or your obligations, your brain feels trapped. At night, your brain refuses to go to sleep because sleep means fast traveling to the next day of work. Staying up late is your brain's way of taking revenge. It is a desperate bid for freedom. It's not that you aren't disciplined enough to sleep, it's that you are starving for control. So if laziness is biological, are we doomed? No. We just need to stop fighting our biology and start riding it. We often assume we should be able to focus for 8 hours straight. But biologically, that is impossible. Our bodies operate on ultradian rhythms, cycles of energy that last about 90 to 120 minutes. Just like you have sleep cycles at night, you have energy cycles during the day. After about 90 minutes of focus, your brain must trough. It depletes its supply of glucose and electrolytes. That lazy feeling you get at 2 p.m., that isn't a character flaw. That is your ultradian trough. Your brain is asking for a reset. If you push through it with coffee and willpower, you trigger a stress response. But if you embrace it, you unlock strategic laziness. When you truly do nothing, not scrolling, just staring at a wall or walking, your brain activates the default mode network. This is where the magic happens. This is called the incubation effect. When the default mode network is active, your brain starts connecting distant ideas in the background. It solves problems for you. This is why ideas come in the shower. You weren't working, you were being lazy, and that allowed your brain to be brilliant. Finally, let's talk about the chemical engine of motivation and how to fix your dopamine system. The goal is to raise your tonic baseline dopamine so effort feels less painful and the reward is greater. Here are the 3 neurochemical hacks to retune your brain. 1. The fast food dopamine detox. This is crucial. For 1 to 3 hours a day, implement a dopamine fast. This means no scrolling, no social media, no YouTube, no snacking, no cheap phasic hits. By intentionally lowering the instant rewards, you increase the sensitivity of your dopamine receptors. It's like turning down the volume on loud music so you can hear the quiet things again. This makes the reward of productive effort, even a small accomplishment, feel much more satisfying. 2. The completion loop. Dopamine isn't just released when you get the reward, it's heavily released right before you complete a task. This anticipation is the true driver of motivation. To exploit this, you must break your tasks down into tiny, satisfying chunks. Instead of write report, which has high cognitive load and low dopamine, make the task write the introduction, 10 minutes. When you check that small box, your brain gets a mini reward, which raises your tonic baseline and gives you momentum for the next chunk. This is a positive feedback loop. 3. The power of predictable pain. Remember, the ACC hates effort. To override it, you must make the process of getting started predictable, not the outcome. The hack is called the 5-minute rule. Commit to working on the hard task for just 5 minutes. Your brain's resistance is highest at the start, when the amygdala sees the threat. By consistently showing your brain that the first 5 minutes are low cost and non-threatening, you reduce the fear response, allowing the momentum to take over. Most of the time, 5 minutes turns into 20, which turns into an hour. So here is your prescription. First, stop the guilt. Guilt keeps your amygdala stressed, which keeps you in that fight or flight paralysis. Second, respect your ultradian rhythms. Work for 90 minutes, then be unapologetically lazy for 20. But, and this is key, practice high-quality leisure. No screens. Let your default mode network run. Laziness isn't a sin. It's a signal. It's your body telling you it needs energy, or your mind telling you it needs freedom. Listen to it. Thanks for watching. And remember, you aren't broken. You're just human. For more videos on how your brain works, make sure to hit that subscribe button. We'll see you in the next video.